Alright guys, welcome to the past papers section here on Orange Tutoring. And today we'll be starting off with the 2019 November Mathematics Paper 1. And this ecexams.co.za, that's where I usually find papers if I'm looking for any mathematics papers. And you can find other subjects there as well. Now I've seen that the results, not the results, the answer sheets for these 2019 papers are not yet out, at least on this site. If you have another site where you know where to find them, please let me know. In the meantime, we'll just solve them without having the answers in front of us. Right, so let's just dive right into it. So question 1.1.1. Okay, 1.1.1. We have to solve for x. And our question we start off is x squared plus 5x minus 6 plus 5x minus 6 equals 0. So that's quite nice. We usually start off fairly easy in these papers just to get the engine sort of revving with a bit of algebra. Okay, so we see this is a quadratic trinomial. We've got everything on one side equal to 0, so now we can factorize, if it can factorize. And my general rule of thumb is if it takes me more than a certain number of seconds to see the factors, then I just use the quadratic formula, unless they specifically tell me to factorize. Right, so this one, since there's no coefficients in front of the x, we know it's a 1, so it has to be just x times x to give us x squared. And for these last two, we know this placeholder times this placeholder must give us negative 6. Alright, and if we add or subtract those two values, so let's try one thing. Negative 6 times positive 1 is negative 6, and then minus 6x plus x, for this one give us 5x. Great, so that's just a little bit on factorizing. For the rest of the video, we're not going to spend too much time on that factorizing again. Right, so now that we know something times, whoa, my brackets are awful, times something else equals 0, then we know either this thing equals 0 or that thing equals 0. Right, so we have x minus 6 equals 0 or x plus 1 equals 0. So this means that x equals 6 or x equals negative 1, and that is our answer. Nice start. Right, then we go to 1.2.2. Okay, 1.1.2, and that says 4x squared. So 4x squared plus 3x minus 5 equals 0, and we are told in brackets give your answer correct to 2 decimal places. 2 decimal places. Alright, correct. Oh, that's not a C, that's supposed to be a C. Right, so as soon as we see that, if we see correct to 2 decimal places anywhere, we know we're going to have to get a non-whole number so that it won't be able to factorize. So then we know we can just plug it into our quadratic formula. What does the formula look like? The formula says that x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And that is it. That looks ugly. Right, so that is our quadratic formula. Now we can just plug in the values. So in this case, we know that a equals 4, right? A equals 4, b equals 3, and c equals negative 5. C equals negative 5. Right, so let's fill that in. Okay, x equals negative b, so it's negative 3 plus or minus the square root of, then b squared, so that's 3 squared, minus 4 times a is 4, and c is negative 5. All of this over 2 times a. Okay, and let's continue. So let's just solve this. Now you can just type that in a calculator. I don't have a calculator, so I'm just gonna get it into simplest root form and maybe use the computer's calculator at the end. So negative 3 plus or minus square root. Here we've got 3 squared is 9, and then the minus and the minus makes a plus, so we've got 9 plus, and then this gives us 20 times 4 is 80, so 9 plus 80, so that is square root of 89. Oh, man, I'll get the writing right just now. A little bit tired. Okay, 89 all over 2 times 4 is 8. So then x equals negative 3 plus 89's square root all over 8, or x equals negative 3 minus square root 89 over 8. And you can just type that in the calculator to get your answers and round them off to decimal places. So I don't have a calculator, I'm not going to do that now. Right, so that was question 1.1.2. Then we get to question 1.1.3. Let me do this in another color. Let's do this in green. Okay, question 1.1.3. Right, so this question we're still solving for x. This question says 4x squared minus 1 must be less than 0. So now I've got an inequality. So with inequalities, they work very similar to equal signs, but with a few differences. Right, so what we can do is we can first do it the normal way. So I think I like to factorize. So this is a difference between two squares. So we know it's going to be 2 brackets less than 0. And what goes in the bracket? So it's a square root of the first thing in the first part. So square root of 4x squared is 2x. One gets a plus, one gets a minus, doesn't matter which way around. Whoa, not a minus 1, just a minus. Okay, and now the square root of 1, that is 1. Right, so now that we've gotten here, now the wrong thing to do, would be to say, aha, so now we can say 2x plus 1 is less than 0, or 2x minus 1 is less than 0, and then solve from here. So then 2x negative 1, x less than negative half, or in this case we'll do the same, 2x 1, x less than a half. So this would be the answer that some people got, and this is wrong. This is not what we want. We cannot just do that. Right, so I'm just gonna get rid of that quickly and then show us what we should actually be doing. Right, so what we actually should be doing is just saying, well, now we have our critical values. Let's write that, critical values. I'm just corting off here. Critical values. Critical values, now we say as if it was an equal sign. So 2x plus 1 equals 0, which would give us x equals negative half, or x equals positive half. Right, so those are critical values. But what do we do with the critical values? We draw a graph of our parabola. This is a parabola, right? Ax squared plus bx plus c. And this is on y-axis. Always good to just label your graphs. So that is our graph. And we know it's a parabola, and these are x-intercepts, negative half and half. So our parabola looks something like that. Right. That value is negative a half, and that value is positive a half. And we wanted to know, where is this graph less than 0? So less than 0 means below the x-axis, not above, but below. So where is this graph below the x-axis? Well, for this part. That's the part where it's below the x-axis, right? And what is that? That is when x is between negative half and a half. So that is our answer. So from here, from critical values, that's the difference between an equation and an inequality. We can't just go from here and say this less than 0 or this less than 0. With an equation we can. Right, question 1.1.4 coming up. Okay, let's go to the next page. Start a new page for this one. Okay, 1.1.4. Okay, so this one, lots of brackets. And if you have the paper in front of you, it would be nice if you could follow along with the paper. So here we've got a big square root, Underneath that we've got a smaller square root with a 32 underneath it and a plus x. Close, and then the other one looks pretty much the same. Big square root, little square root with a 32 underneath it and a minus and an x. Okay, I didn't have to write it that big, but at least now we can see where what is. That's all equal to x. Alright, so in this case we want to get rid of square roots. So a couple of ways you could do this. You could first multiply these two brackets out, and that'll be completely fine. That's actually probably the first thing I thought of. And the other thing, you can square both sides, and I think we're going to go for that option here. So we're going to square both sides. So we're going to say this thing squared and this whole thing squared. Right, so what does a square do? It goes to both parts, right? Not both terms. So this thing gets squared, this thing gets squared. So if this thing gets squared, the square and the square root cancels out. So what's left is the square root 32 plus x times, and this side, this one also gets cancelled out by that square. Square root 32 minus x. That's equal to, and x squared is just x squared. Yep, that's it. And now we can multiply out with our FOIL method. Right? So we do that. So that means we get 32. Then that. So that is minus root 32x. Then this part plus root 32x. And x times negative x squared equals x squared. Alright, so these two can cancel out. Oh, not that part. Still getting used to this writing on a computer thing. Right, so this negative something plus that same something is obviously 0. So we have 32 minus x squared equals x squared. So 32 equals x squared plus 2x squared, plus x squared plus x squared, which gives us 2x squared, divided by 2, 16 equals x squared, and then we can take the square root of both sides. The square root. So we take the square root of both sides, and so this side is now x, and what is on this side? 4, right? But not just 4, plus or minus 4. So that will be our answer for that one. Now another way, let me just maybe show you the other way we could have done this, is we could have had let's do it from here. So we could have had everything on one side, so 32 let's say, okay, let's keep it like that. So 32 minus 2x squared, right? If we brought everything to the left, then we could take out a 2 as a common factor, and we'd have 16 minus x squared equals 0. Divide everything by 2, and we could have actually done that in the previous step already. So we just have this 16 minus x squared, and we can factorize that into 4 plus x, 4 minus x, and that'll give us x equals negative 4 or x equals 4. Right, so we see we get the same answer, plus or minus 4. That was 1.1.4. 2 more questions for this video. I know it's quite a lengthy one, but I just wanted to get a couple of things covered in the first video already. Right, 1.2. Question 1.2. 1.2. So this question says we have to solve simultaneously for x and y, and we get given 2 equations. Our first one is y plus x equals 12. Yep, just making sure I'm writing down correctly. And the other one is xy equals 14 minus 3x. xy equals 14 minus 3x. Right, so those are our equations. Now, what I'm going to do is I'm going to rewrite this one to become y equals 12 minus x. Right? Doesn't matter if you get x or y by itself, but we do want one of them to be the subject, so we can replace that in the next equation. So I choose y to be my subject. So now what I do is, in the second equation, instead of y, I'm going to write 12 minus x, right? Equals 14 minus 3x. Right, so all I did was just replace the y with what y actually is, 12 minus x. And now we can multiply it. So this gives us 12x minus x squared equals 14 minus 3x. And then let's say we take everything to the right. So this becomes positive x squared minus 3x minus 12x is minus 15x. And then plus 14. And again, this one we can factorize, and for me, if I don't see the factors in like 3 seconds, then I just use the formula, otherwise it feels like I'm wasting time. So x and x, factors of 14 is 1 and 14, so minus 14 minus 1, so negative 14 times negative 1 gives us positive 14, and negative 14x minus 1x minus 15x. Perfect. Alright, and then we get x equals 14 or x equals 1. So there's half the question done. Now we need to find the corresponding y values. Right, the corresponding y values. So we'll say y equals, when x is 14, so when x is 14 we've got y equals 12 minus 14, which gives us y equals negative 2. And in this case, when x is 1, we've got y equals 12 minus 1. 12 minus 1, so y equals 11. And then usually we want to write this in coordinate form. So our answer for this would be, let's write it here. Our answer would be either 14 and negative 2, or 1 and 11. Right, so these will be our answers. That'll be our final answer in coordinate form. Okay, one last question for today, for this video. And let's start a new page for that one. Right, last question. Question 1.3. 1.3. Okay. So, this is a brilliant question. So it says, I'm going to write this down just for those of you who can't see it on the paper. Consider, so this might take a little while, consider the product 1 times 2 times 3 times 4 times all the way up to times 30. Right, consider that product, and then determine the largest value of k, the largest value of k, such that 3 to the power k, so such that 3 to the power k is a factor of this product, is a factor of this product. Alright, so now that we have the whole question there, so the important part here is let me do another color for that again. So here, so that is our number or our product, and this is the other thing we have to look at. Right, so what do we do here? So we want to find, so 3 to the power what? 3 to the power 5, 3 to the power 8, which one of those things is the largest that is still a product factor of this? Right, so I think the best way to approach this one is to say, well, this is a big number, right? And it's already broken down into products for us. So all we need to do is find the prime factors of each of these things. So there's a slightly quicker way, but I'm going to do the long way just for us to see exactly what's happening here. Exactly what's happening. Okay, so 2, okay, 1 we can write as 1. So 1 is just equal to 1. 2 is 2. 3 equals 3. Okay, it's quite boring at the start. 4 Okay, 4, that is 2 squared. 5 is just 5. 6, that is 2 times 3. 7, that's just 7. 8, that is 2 cubed. 9 equals 3 squared. 10 is 2 times 5. 11 is 11. 12 is 2 squared times 3. 13 is just 13. And let me know if I make any mistakes while I'm doing this. 14 equals 2 times 7. So we're just doing the prime factors of each thing, right? Of each factor. 15 equals 3 times 5. And I know this seems a little bit tedious, but the nice thing, if we do it like this, all we have to do is count at the end. So 16, 2 to the power 4. I'm just going to go a little bit quicker here. 17 equals 17. 18 equals 2 times 3 squared. 19 is a prime number, so that remains 19. 20 equals 2 times 2 squared times 5. Sorry, let me erase that. See, going quicker didn't help. Okay, 2 squared times 5. 2 squared times 5. 21 equals 3 times 7. Now the important thing here is only the things that contain 3's as factors. So that's probably the quicker way to do it, even if you're writing lots of things out. 2 times 11. 23, but just bear with me. 23 is a prime number. 24, what is 24? Well, 24 is 2 cubed times 3, I think. 25. 25 is 5 squared. 26. 26 is 2 times 13. 27, that is 3 cubed. Only a couple more. 28, that's 2 squared times 7. 29 is a prime number. And 30 equals 2 times 3 times 5. Alright, so after all of that, what did we accomplish? So we want to find if, so this is now, this is basically this whole number split up into its prime factors. Because we took factors we already knew, 1, 2, 3, 4, 5, 6, 7, 8, etc. and took the prime factors of those. So now, to find the complete prime factorization of this thing, we can just add all of the, say we want to find how many 2's there are. So it's 1, 2, 3, 4, 5, etc. We can count the number of 2's. So we want the number of 3's. So we'll just count the number of 3's. Right, so let's do that. So we've got 1, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 3 to the power 14. That'll be our answer. Right. So that's quite tedious. So like I said, if you want to do it slightly shorter, what we could do is we could just think of all the numbers that contains 3's as the factors. So we could think, okay, 3 is a factor of 3. So pretty much you could just say everything that let me do this in a slightly other color. So we could say everything that's all the multiples of 3. It's the only numbers we have to look at. So that would be 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. And we only have to do those ones. Like we see 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. So those are actually the only ones we need to look at. But I just thought I'd do everything so we could see that's the answer. And we could do the same for 2's if we wanted 2's or 5's or 7's. But I thought that was quite a good question. Okay, that is it for this first and very long video. Hopefully I'll be uploading another one very soon. I'll try to do at least one a day until we finish this paper and paper 2 for 2019 November. And thanks for joining.